Hello? Hello. Hi, everyone. If you can please take your seats. We are about to get started with our second tracks. Everyone, if you can please take your seats. I'd like to introduce our next speaker. We have NENG CHIEH from Wiwynn, who's going to be talking about long-term reliability for single-phase immersion cooling. Everyone, if you can please take your seats or take your conversations outside, we would appreciate it. People, we're about to start. Thank you. Samantha, can you please sit down? Samantha.
Hello, everyone. I'm Jerry from Wiwynn Thermal Engineering. It's great to be here in OCP. Today, I will talk about the topic for the long-term reliability testing of single-phase immersion cooling. Okay, and we want to see how the system performed after long-term operations and to see what factors will impact the stability. Here's a quick look at the outlines. The first, we'll just go a brief overview of the liquid cooling evolutions. And the next, we'll focus on the single-phase immersion cooling. And then we'll talk about our assessment studies. Then finally, it's about our long-term test introductions, including the test plan and setup, and we will share some key results and our analysis. Okay, in the recent years, we have seen that the explosive growth of the AI and high-performance computing workloads, especially for the large-scale trainings and cluster GPU. Yeah. So the traditional air cooling capability now almost reached its limits. So as the high power density keeps increasing, new data centers now are being designed with the liquid cooling at the facility levels with the dedicated water infrastructure to support it. So there's two kinds of liquid cooling approaches in data centers now. The first one is a direct-to-chip, where the coolant will go through the pipes and to the cold plate, which is directly attached to the chip. But we should have it's efficiency, but we should have to deal with the complex pipe routings and fittings and manifolds, and we should also have to handle the potential risk of the leakage. And the other method is for the immersion coolings. The immersion cooling is that we put all the servers into the tank, which is filled with the dielectric fluid. Okay, so next. Here's for the single-phase immersion coolings, there's a few technical advantages. The first is we know that it has a better heat uniformity, which means the more uniform of the component temperature across the system. And it's simpler to operate, and also it has a low noise, and the mechanical complexity is lower compared to the DLC in server. But we still need to have some potential concerns. Is for the first is fluid stability over time, and also for the system performance. And we'll also need to consider if there's mechanical parts is reliable after the long-term exposure to the liquid. So that's why the long-term reliability testing is very is very important. We can validate the system durabilities, and we also can establish a kind of maintenance guidance, and to reduce the deployment risk before the large-scale deployment in data center. And here's our long-term assessment studies. We'll focus on three aspects. The first one is the fluid characteristics. Actually, we have cooperate with our vendors, liquid vendors, and they will help us to analyze the liquid after a period of use. And we will try to see if it still can meet the OCP requirements. And the second one is the system performance. We will collect the data such like the CPU power, temperature, and frequencies, and the memories, and the bandwidth, and the FPGA cards, NIC cards. And we'll collect those data to see if there's any performance fluctuations. And the third one, we will also monitor and observe those mechanical parts compatibilities. If there's any crack or broken or any material degradations happen or not. Okay, and then we'll go to our validation schedules to get trustable information and result. So we planned 24 weeks. It's a long-term test. We can see that we start from the baseline. We do the air cooling first, and then we put into the immersion cooling tank, and to start the test around the end of June this year. And until now, the OCP submit time is now to week 16. And so the test is still ongoing on our lab. Okay, here is just look for our tank architectures here. The immersion tank is ORV3 rack structures here, and we use the Microsoft Azure computing servers. And coolant type is synthetic ester-based fluid, which is it complies with the OCP requirements. And there, the table is some of the main properties of this kind of fluid. Okay, so for the immersion tank architectures, let's talk about its power delivery. There's a power shelf inside there, and the AC power will input from the power whip, and it will transfer to the DC via this power shelf. The power shelf it's a kind of individual PSU clusters. So those PSU can be hot swappable, and also can be redundant. So it's totally aligned with the ORV3 standard. And also after the power shelf delivers the DC power, it will to the bottom side, there's a DC bus bar. And once we insert the server vertically into this tank, and it will be power on. So that it's very convenient to change from air cooling server to this, and change air cooling liquid server to apply in this immersion tank environment. Okay, and here's our system configurations. There's two CPU, 24 memories, and FPGA, and 2 U1.S and 2 M.2s, and also lists out our stress tools. In the right side of the tables, we have collect those data of the devices, the power temperature and the frequencies for CPU, and the power temperature and the bandwidth for memory, the IOPS for UNDIS, and the network transfer rate for this FPGA card. Okay, let's go to the result. The first one is about the CPU. And the first result is that we have the stable CPU frequencies across all the test weeks, but only with some minor variations from the baseline. And also the temperature remained well below the critical limits. Okay, and in the result here, there is no signs of the performance degradations over these 30 weeks. Okay, the second is the result of the memories. The first is about the bandwidth for the read and write. There's a very consistent result compared to the baseline. Okay, and the power is also very stable until now. And the temperature is well below to the baseline, which means that the thermal controls of the immersion cooling is very workable for those things. Okay, the third one is about UNDIS IOPS. Here in these diagrams, we can see that it's a stable it's very stable, the IOPS result. But we just found that if we compare to the baseline of the air cooling and liquid cooling, we found that there's about 30% higher degradations there. Yeah, but after we immerse to immersion cooling, and we just found that there's no more degradation trend until now. And for this one, we will do the further studies and with our liquid vendors and also our UNDIS vendor to see what may be the reason of this issue. Okay, the fourth one is about the FPGA card for the network transfer rates data. And the throughput maintains at 90 to 99 gigabits per second. It's a little above the air cooling baselines, but the performance is close to the original liquid cooling baselines, showing that it's still high efficiencies, and there's no long-term degradation found until now. Okay, and another test result, there's about the material incompatibility risk. We just found that there's a pictures, we see there's the brokens and some of the connectors have a crack, and also the hub and the latch. And I think that we should have to go to overview the material bond first before we do the simulations, immersion cooling validation. Yeah. Okay, and the sixth one is about the liquid inspection. Yes, it's our liquid vendors just help us to analyze the contents of the liquid after 10 weeks used. And we just found the results show that it still meets the OCP requirements. So now our test is still ongoing. Okay, let's go to the conclusions. The first is about the performance stabilities. I think except the UNDIS IOPS, there's still degradation issues. We should go further inspection and do study for that. And other CPU memories and FPGA card performance, it can still remain consistent now. Okay, and the second one is the material compatibility challenges. As the previous picture shows, there's still we should do inspections and do overview the BOM check for those material check to choose the better one, which is compatible with the liquid cooling, the immersion liquid. Okay, and the final one is that we will highlight again the importance of a long-term reliability test, which this extended validation is very essential to address the material durability and ensure our sustained reliability in these single-phase immersion systems. Okay, so for the call to actions, if you are interested in those immersion coolings, you can involve the OCP server projects and also the OCP immersion sub-project. And for our tank information, the Wiwynn site have a related white paper talk about the ORV3 architecture, servers, and the tank. And the final one is that if you are interested, you can go to the Persto booth to find out more detail for their liquid. And thank you so much for your listening.